Hello, and welcome to this quick take video focusing on customizing and instantiating IP within the Vivado Design Suite. The Vivado Integrated Design Environment is a new and powerful tool for the creation, analysis, and validation of designs. It provides IP-centric system-level integration. The IP catalog provides an easy way to browse and search for IP. You can select and configure IP from the IP catalog and add and instance it into your design. You can create a standalone IP project. This allows you to implement and validate the IP by itself. You can either export a netlist for use in your design or read the IP and synthesize it with your RTL. Here we see the Vivado Integrated Design Environment with the WaveGen sample design loaded. This design has been modified and one of the IPs has been removed. To add it back, we can go to the IP catalog, which is available in the Flow Navigator. We select this and the IP catalog comes up. IPs are grouped by categories. We can browse to the category and IP that we're interested in, or we can go to the search bar and type in a keyword. When an IP has been selected, we can see what interface, status, and licensing information is available, and below we can see details about the IP. To customize it, we double-click. The Customize IP window comes up. This is unique for each IP. We can resize it to see the symbol. We can show disabled ports. We can zoom in and resize the display just like we can in the device view. Turning these off, let's call the component name char_FIFO. We can either have a native or AXI4 interface types. If I select AXI4, you can see the symbol changes. For this design, we want a native interface, so let's go back to that. Going to the implementation type, we want to have independent clocks. So let's do it with a block RAM. We can see the symbol updates. In the native ports tab, we want to make an 8-bit interface. So we'll select the right, and we'll see the read changes as well, and the symbol reflects it. The flags, the reset and programming flags, and the data counts, those tabs we're not going to change. We can see a summary of the IP that we have created, showing what resources is used as well. Now we'll press OK to add this to our design. Our IP has now been added to the design. Let's go to the IP sources, and we'll see character FIFO. Expanding this, we'll see there's a synthesis and instantiation template. Let's open up the template. It's a VEO file, meaning this is a Verilog template. It's Verilog because in our project settings, in the General tab, under the target language, we have Verilog selected. We can generate other targets by right-clicking on the IP and go and generate. Let's say we want to add a simulation file. Select that and press OK. A new file is added, we see, for simulation. Let's go ahead and actually add this IP into our RTL. Let's copy the template, go into our hierarchy, into the RTL file that we want to instance this, and let's put it down, let's say, right here. So I paste that in. Now I need to edit this to match my names. Let me do that real quick. There. We'll see there's an asterisk there showing that this file has been modified. Let's save it. The hierarchy will update, and then we'll see character FIFO listed. There it is. Now I can select this and set it as the top of the design. I can then synthesize this standalone and write out a netlist if I wanted to. We'll do that later. Let's elaborate the design. If I go to the RTL netlist and select character FIFO, we'll see that it highlights in the schematic. Let's zoom in there and take a look at it. There it is. Zoom back out, and we're done. We have now gone over all the steps necessary to customize and add an IP into our design. Now let's go over how to work with IP standalone. Here we have an RTL project that I have added the FIFO IP to, following the same steps we just went over. This project started as an RTL project in which I added no RTL sources. We could add other IPs to this project and work with each as top. Let's just stick with the character FIFO, and let's generate some more targets. Let's generate simulation and test bench targets. Now let's look at those targets. The simulation and test bench targets are provided by the FIFO IP. If we wanted to, we could launch simulation at this time. When synthesizing the IP standalone, we want to prevent the automatic insertion of I/O buffers. This is because the netlist that we produce, we might be tying on to internal logic and not directly to an I/O port. So we want to make sure the netlist that we're producing doesn't have those I/O buffers inserted. We go into Synthesis Settings and select the No I/O Buff option and press OK. Now the netlist we produce when we synthesize will not have I/O buffers. Let's go ahead and run synthesis, because what we want to do is generate a netlist. Synthesis runs, completes, let's open it up. And now let's write out a netlist. We can do this one of two ways. We can go up to File and export a netlist. We can either do an EDIF or a Verilog structural netlist. Another way we could do this is from the Tickle console. We can directly type in write Verilog and give it, whatever file name we want to. Let's just call it char FIFO. There, now a netlist has been written out. We can work with that netlist, or if we wanted to, we could work with the XCI file directly, assuming we're working with an RTL project. This can be used in either a non-project flow or a project flow. I've demonstrated some of the IP-centric system-level capabilities of the Vivado Integrated Design Environment. It offers plug-and-play IP with AXI support using the IP-exact standard. I have showed how to use the IP catalog to select, configure, and add IP to a project. You can create and validate IP from within a design or standalone. You can synthesize IP to generate a netlist standalone for use in your flows. Thank you for your time. I hope you found this demo useful. For more information, please see the other quick take videos and the Vivado user guides.